And we're back. Now we just talked about the product of powers, the first of our properties of exponents, and now we're going to actually apply that property because there is a very, very important technique in algebra that we use this particular property for, the product of powers, and that's when we multiply polynomials together. So let's take a look at an example. Let's start with a real simple example first. How about 6x squared times 5x plus 8? I probably don't have to tell you that if we want to expand this, that's simply a matter of distributing. We're going to multiply the 6x squared times the 5x and the 6x squared times the 8. So let's go ahead and do that. 6 times 5, 30. And here's where our property of exponents come in. X squared, there's my x squared, times x, 2 plus 1 is 3. There's our property of exponents, our product of powers when we add the exponents. And then 6x squared times 8 is 48x squared. Pretty easy. I hope you see that. Moving on, let's do something a little more complicated, although again it's probably something you're going to recognize. And how about we do this? 4x minus 7 times x plus 8. You're probably all saying, I know how to do that. That's foiling. Yes, it is. Foiling means it's an acronym that we use to remember what we need to do in a situation like this, and that is that every term in the first parentheses, the first factor, has to be multiplied by each term in the second. And we do that, we remember that by using the acronym FOIL. F for first, multiply this term times this term, the first one in each case. Outside, multiply this first term times the last term, the two outside terms. Inside, I, this term times this term, the inside terms in each case. And the last, L, the last terms in each case. So let's do that. 4x times x. 4 times 1, there's a 1 in front of that x, is 4. And then using our product of powers, 1 plus 1 is 2. Outside, 4x times 8 is 32x. Inside, negative 7 times x, negative 7x. And last, negative 7 times 8 is negative 56. And then I think you all know what to do here. We need to combine some like terms. And our two like terms are right here. There they are. We have 32x minus 7x. We have 4x squared. 32 minus 7 is 25. And negative 56. So there's your answer to that polynomial multiplication. A polynomial, by the way, we haven't really gotten to it yet in our videos, is a expression which has a number of different terms in it that are added together. For example, this one has 2 terms. That's actually called a binomial. So this is a binomial times a binomial. We'll get to these later, but this one here that has a single term is called a monomial. So what happens if we make them even more complicated? What if we've got, and let's use a different variable other than x. It doesn't always have to be x. Let's use an n this time. What if we have 6n plus 4 times n squared minus 5n plus 8? A little different, isn't it? Can't foil this one. Okay, the reason we can't foil this one is because this second term right here, the second factor has 3 terms in it instead of 2. This is called a trinomial. Should make sense since the one with 2 is called a binomial. So, but the process remains the same. We have to make sure that everything in our first factor, that's our first factor, which is a binomial, is multiplied by everything in our second factor, our trinomial. So what we're going to do here is we're going to multiply this first term times everything in the second, parentheses, and then we're going to multiply our second term by everything in the second, parentheses. Just have to make sure that everything in the first gets multiplied by everything in the second. So let's do that. And again, we're going to use our product our product of powers rules when we deal with the exponential parts of each of the terms. So 6 times 1 is 6. And we've got n to the first, times n squared. 2 plus 1 is 3, n cubed, or n to the third. Now, the first term times the middle term. That's 6n times negative 5n is negative 30n squared. And then my last term, 6n times 8, is plus 48n. And doing our second term, we've got 4 times n squared is 4n squared. That's an easy one. 4 times negative 5n would be negative 20n. And 4 times 8 would be 32. And the last thing we have to do is combine some like terms. It is best in all of these problems to leave your answers in standard form. You'll notice that both in this answer here that I did up here, I go from 3 to 2. They decrease, the exponents. Here I go from 2. There's a 1 here that's understood. And this is actually x to the 0, although we haven't gotten that yet. But they go down from 2 to 1 to 0. So we want to have these exponents in decreasing order as well in a nice standard form. It's just convention. It's the way it's done. So we're going to stick with that. So our first term is 6n cubed. There are no like terms with that. That's the only cubed term. We can only add together or subtract things that have the same power of x. Now let's take a look at our n squared terms. There's 1 and there's 1. If I take negative 30n squared and add 4n squared to that, negative 30 plus 4n is negative 26n squared. And then I have two single n terms, 2n to the first terms. They are 48n and minus 20n, so that's plus 28n. And then my last term is the solo constant term with no n, no variable, is the 32. So our answer there is 6n cubed minus 26n squared plus 28n plus 32. There's actually another way to do this too, and actually it's a way that I prefer. Let's think back to elementary school. What if I'd given you this problem in elementary school? Let's see, 234 times 12. Remember long multiplication? I know it's a long time ago and you're used to using a calculator now, but let's remind ourselves what we did. We did 2 times 4 is 8. Then we did 2 times 3 is 6. 2 times 2 is 4. When we went to our next number, the 1 here, we moved over one space, or you put a 0 there. I learned just to move over a space. So 1 times 4 is 4. 1 times 3 is 3. 1 times 2 is 2. And then what we did was we added these together in columns. 8, 6 plus 4 is 10. Carry the 1. 1 plus 4 is 5, plus 3 is 8. 2808. Well, actually, you can do the same thing with these polynomial problems. N squared, I'm using this last one I just did, minus 5n plus 8 times 6n plus 4. Exact same thing we just did with the numbers. 4 times 8 is 32. 4 times negative 5n is negative 20n. 4 times n squared is 4n squared. Okay, and then move over, or put a 0 there if you want. 6n times 8 is 48n. 6n times negative 5n is negative 30n squared. And 6n times n squared is 6n cubed. The really nice thing about this technique, this way of doing it, is you'll notice that you don't have to go hunting around for like terms, because the like terms all line up in nice columns. So let's add those. We got 32. Negative 20 plus 48 is 28n. 4 minus 30 is negative 26n squared. That was a plus 28n, and 6n cubed. Same answer, just a different way of doing it. Does it matter which way you do it? No, whichever way works best for you. I happen to like this way better. The only difficulty with this is if you have a situation where one of your terms is missing. For example, if you had oh, I don't know, x plus 1 times x cubed plus 3x minus 7. You'd have a little difficulty with this because you're missing, in this particular factor here, an x squared term. It's going to cause some holes in this, and you have to keep track of things that you normally wouldn't have to keep track of. So this kind of technique actually works best if you have polynomials that are in standard form, decreasing powers, and there are no missing terms. That's your best, this is your best bet for that. And I think you can see, I hope, that if we made this one step more complicated, and that made a trinomial times a trinomial, let's do, how about x squared minus 4x minus 4 times 2x squared plus 8x minus 4. And again, we want to multiply everything in our first, each of the terms in our first factor, times everything, each term in our second factor. That's a little better. So let's go ahead and do that. We're going to do this pretty quickly. I don't want to spend too much more time. So x squared times 2x squared is 2x to the fourth. Product of powers, 2 plus 2. X squared times x squared, x to the 2 plus 2 is x to the fourth. So 2x to the fourth. X squared times 8x is 16. Oh, no, it's not. Let's erase that. You didn't see me do that, did you? No, you didn't. Okay, let's go back to where we were. X squared times 8x is 8x cubed. That's better. X squared times negative 4 is negative 4x squared. So there's our first term times each term in the second parentheses. There's that times then that and that. Now we want to do the second term. So we've got minus 4x times 2x squared is negative 8x cubed. Negative 4x times 8x is negative 32x squared. And negative 4x times negative 4 is negative, no it's not, it's positive 16x. And then our last one. Let's do this in a different color because we're getting a lot of arrows here. There we go. We're going to do this times this. So that's negative 4 times 2x squared is negative 8x squared. I'll just keep it in red. What the heck? Negative 4 times 8x is negative 32x. And negative 4 times negative 4 is plus 16. And then all we have to do is add up our like terms, combine our like terms, and keep it in standard form. That means we're going to start with the highest power of x, which is x to the fourth. X to the third, we have an 8x cubed minus 8x cubed. Well, looky there. They cancel each other out, so we don't have an x cubed term. All right, what about our x squareds? We have minus 4x squared, and we have minus 32x squared, and we have negative 8x squared right there. And if we add those up, negative 4 minus 32 is negative 36, minus 8 is negative 44, and squared. We got rid of our cubed term because it canceled out. And then our x terms, we have 16x minus 32x is negative 16x. And then we have our 16 left at the end there, our constant term that doesn't have a variable. There's our answer. Okay, so that's multiplying polynomials.